Hello again, welcome to Maths is Not a Mystery. We're going to be looking at percentages today, and this is going to be the first of a number of videos all about percentages. Percentages are a huge part of maths, both in your exams and actually in real life, which is why they're a huge part of maths generally. We're going to start with the basics here, really basic stuff, just to make sure that you fully understand what percentages are all about. So let's get going then. Percent actually means out of 100. Okay, the cent part there is the 100, like there are 100 cents in a dollar, 100 cents in a euro, centimetres, 100 centimetres in a metre, and so on, per out of. Okay, and the point of doing percentages is basically so that you can compare things that would otherwise be difficult to compare. And I'm going to give you a few examples here. Look, if we get some test results, let's imagine we've got 4 students here and they've each done a test. They've each gone with different teachers, and the teachers have devised their tests, and they've done different kinds of tests. The first student did a test out of 100. The second did a test out of 50. The third one had 25 questions, and the final one had only 10 questions. It's very difficult at this point to say who did best and who did worst, because they've answered a different number of questions. They've all got some wrong. But is it relevant that this person got 4 questions wrong, whereas this person got 8 questions wrong, and this person got a lot more questions wrong? Is it relevant because they answered a different number of questions in the first place? So it's impossible to just compare straight out by looking at them. That's the point of percentages. If we turn them all into percentages and we say that they were all out of 100, suddenly it's much easier to solve the problem. Now this one's already out of 100. When the fraction looks like this and there's 100 at the bottom, it's a percentage. So that is 76%. Done. No more to do with that one. The next question, though, has got a 50 at the bottom. The way we have to think now is, how do we make that into 100? Now, there are 2 ways. One way is acceptable, the other way isn't. You could double it. That's acceptable. The other way is to add 50. Now, don't ever add or subtract when you're dealing with percentages like this. Because when you add or subtract, if you added 50 to this, you'd have to add 50 to that. And that would then say 92 out of 100, which might not be the same. What we have to do is we have to increase it in proportion. And you can only increase or decrease in proportion if you multiply or divide. So multiply everything in this one by 2. Double the whole lot. So the bottom line says 100. The top line, 2 42s are 84. Now it looks like this. It's over 100, so that's 84%. You see why the 92 would have been wrong if we'd have just added it. Okay, so we can see that this student has done better than that student because they've scored 84%. So let's look at it with this one now. 25 is our number that we were counting out of. How do you make 25 into 100? Well, you can multiply it by 4, can't you? If you multiply 25 by 4, you've got 100. If you multiply the top by 4, well, 2 18s are 36, and 2 of those are 72. Now it's a percentage, 72%. And the final student was doing a test out of 10. To make that into 100, of course, we'd have to multiply everything by 10. So 10 10s are 100, 10 6s are 60. So that student got 60%. And now we can compare them. It's much more easy to compare when we've got them all set out as percentages, as though everybody had done 100 questions, even though they actually haven't. All right, now that can carry on with different numbers. Let's take a look at some of these. Actually, before we do that, I'm going to suggest something else. I'm going to go to the bottom and say what would happen if we had somebody who'd done a question out of a test out of 30. Let's say that they'd done 21 out of 30. Let's think, how could we turn that into 100? we couldn't turn it straight into 100 because you can't multiply 30 up like you can with these numbers and get 100. But what you could do is you could divide it by 3 to make it a 10 on the bottom, and then you could multiply that by 10 to make it 100 on the bottom. And if you did the same thing here, 21 divided by 3 is 7, and then times that by 10 makes 70. So then we'd be able to say that that is 70%. So the numbers that are like on the 10 times table, you can divide them to make them become 10, and then you can multiply it up to make 100. And that's what I was going to show you with this next one here, 4 out of 5. Well, 4 out of 5 is okay, because to make 5 into 100, multiply it by 20. So multiply the top by 20 as well. 20 lots of 4 would be 80. That's 80%. But now, if we look at the 35, that comes to a similar question to the one that we had with the 30. That's not a multiple of 10. It is, however, a multiple of 5. So what we could do is we could make it so that we go down to 5. How do you get 35 to become 5? Well, how many 5s are there in 35? There are 7. Divide it by 7, and then multiply that 5 up to make it 100. So let's do the same with the top. Now I've chosen numbers here that I can do in my head. Usually these things will be calculator questions, so don't worry about if this number was 25 and we had to divide it by 7, because you'd have a calculator. But actually 28 divided by 7 is 4, and multiply that by 20. 4 20s are 80, and it's 80% once again. And you can see that halfway along we ended up with the same number anyway. Okay, so all we did is we took that down, all the way down to 5, and then we multiplied it back up to 100. But what happens when you can't do that? Look at this question below. Let's see a test now. You've got 52 out of 61. There's no way that you can make that become 100 unless you divide it by 61 and go all the way down to 1, and then multiply it by 100 and get it all the way back up to 100. But when I just said divide by 61, look at what this says here. It could be a test score, 52 out of 61. It could be a fraction, 52 over 61, or it could be a division sum. It could actually be 52 divided by 61. And I just mentioned about divide by 61. And if we did 52 divided by 61, obviously we would need a calculator. Let's just put a calculator on here and do that where you can see it. So we're going to do 52 divided by 61, and that gives us this unpleasant answer. I'm going to round it off to 0.85. Okay, 0.85 is our answer there. And I already said we've divided it by 61. That makes it go down to just 1. We need 100 of those to get up to 100. So if we now times that by 100, that becomes 85, 85%. And so this is the way that we can work with any number at all. It will work with these as well if we want it to. Any number at all, however, let's pick a random one, 39 over 43. We know that that's going to be a good score, don't we? Because we should always be estimating. If you got 39 out of 43 in a test, you'd have quite close to full marks. So we should be expecting our answer to be like up in the 80s and 90%. And if our answer isn't anywhere near that, we've done something wrong. But let's look at what it's telling us to do then. It's saying 39 divided by 43. And then that's going to ask us simply to multiply it by 100. And that's going to give us the percentage. So let's take a look at it. So we've got 39 divided by, oops, excuse me, let me do it again. 39 divided by 43, sorry for waving it around, equals 0.906. I'm going to round that off to 0.91. And then we multiply that by 100 and it's 91%. And we said it ought to be up in the 80s or 90s because it's kind of a good score. So there we go. That's how you would convert any complicated number. Have you noticed this link? 0.85, 85%, 0.91, 91%. This is a common thing. And this is going to take us on to our next set of questions, because what they often like you to do is convert between fractions, decimals and percentages, because they're all different ways of saying the same thing. So let's try it. Let's take these numbers here and convert them into all of the other versions. So starting with 4/5, what did we say we'd do with a fraction? We said we would do 4 divided by 5. And if we do 4 divided by 5 in our calculator, 4 divided by 5 is 0.8. So as a decimal, it's 0.8. As a percentage, what would that be? Well, we've got to multiply by 100, remember, so let's just remember that that's like 0.80, so it's 80%. Okay, so 4 divided by 5, 0.8. You do need two numbers after the point if you're going to make it a percentage. Let's do this one. We've got to change it into percentages and fractions. Well, there's no need to even think about the decimals to percentages. This is 63%. That's it, dead simple. How would we do it as a fraction? Well, remember, percentages is out of 100. This is actually 63 over 100. And what you would then do, of course, is you would take a look to see whether you can simplify it. You can't simplify this one, but in some cases you could, so you would, if necessary, do other things to make it into a simplified fraction. And the final one, changing the percentage to a decimal or a fraction. Well, quickly we can change it to a decimal. It's 0.42. No questions there. This one, 42 over 100. Now you can simplify that. You can make that 21 over 50 because they can both be halved. 21 and 50 don't share a multiplication table, so that's it. That's the simplified fraction. It's 21/50ths. Okay, so switching between decimals and percentages, exceptionally easy. Moving from a fraction to either of the others, it's just do the division sum. And moving from a decimal to a fraction, put it over 100 and simplify it if you need to. Now that's it for the basic percentages. There are more videos that will take you on to more complicated things in percentages, so please go ahead and watch those if you fully understand that. And use the Maths is Not a Mystery book that's available on Amazon if you want more practice and some practice questions to try. Thank you for watching, and I hope that's been useful, and we'll see you soon. Goodbye.